Hi, I'm Helen. I work at the School of Physics and Astronomy in Monash University in Melbourne, Australia. Here is my FameLab entry. Let me ask you a question. What is mass? For everyday objects, we tend to think that it's just how much stuff there is of a thing. If I have a cricket ball, and I know how dense or tightly packed the material is, and I know the volume, then I can calculate the mass. But for a fundamental particle, which I cannot break up into smaller pieces, the notions of density and volume cease to have any meaning. Instead, Einstein taught us that mass and energy are really just two sides of the same coin. So a particle has mass from how quickly it's moving, but also when it's not moving, it has a rest mass. That rest mass is really just how much energy it takes to create the particle. It's a fundamental property in the same way that the charge is a fundamental property of an electron. Knowing these rest masses of fundamental particles tells us something about the kind of universe we're living in. And so physicists want to have precise determinations for what they are. The heaviest fundamental particle that we know of is the top quark. It's about as heavy as a gold nucleus. That might not sound that heavy to you, but to give you a sense of scale, if this cricket ball represents the mass of an electron, then the top quark mass is represented by a plane. So let's say I want to measure my top quark mass. I can't very well put it on my kitchen scale. In fact, it's pretty hard to measure very much at all about it, because it decays into other particles in a trillionth of a second, which is inconceivably fast for you and me. So instead, we have to indirectly reconstruct it by looking at the energies deposited in our detector from its decay products. But there's another problem. The top quark can radiate before it decays, and its decay products can also radiate. So when we add it all back up again, the mass we see can get blurred out. If we want to get an accurate measurement, we need to know how much radiation is being produced. That's where I come in. I write computer simulations that model how much radiation is being produced by the top and by its decay products. By comparing to data, we can extract an accurate value for the top quark mass. Thanks for listening.